Hi everyone, let's solve good problem number 46, this permutations. So we have been given an array nums of distinct integers and we need to return all the possible permutations and we can return the answer in any order. Let's try to break the problem statement. So we would be given an array nums of distinct integers. So it is guaranteed the array that would be provided to us will consist of only distinct integers. For example, here you can see we have been given an array nums and elements are 1, 2 and 3. So all are distinct. Okay. So it is always guaranteed. Like array will consist of distinct integers only. And we need to return all the possible permutations. Okay. So for any array, let's say like 1, 2, 3. So by different possible permutation, it simply means like you can place the elements at any index. Okay, like this is also one of the possible permutations. Here what I did, here I just replace the element that is present at index 0 with the element that is present at index 3. Similarly, like this is also one of the possible permutations and it will continue 3 something like this. So these are all the possible permutations for the original input array 1 to 3. Okay, and while returning the answer we can return it in any order. So it doesn't guarantee it like it should always follow this pattern only or this order only. You can return your answer in any order by that, like let's say like your output or the approach that you have written or implemented is returning 2 1 3 first and then returning 1 2 3, then it is also acceptable solution, so there is no issue with that. And after that few more elements. Okay, so ordering of the individual array that is present in the output, basically this list of integer ordering doesn't matter. Okay, so like 2 1 3 could be present at index 1 0 or it could be present at index 3 also, it doesn't matter. Okay, I hope like we are good with the problem statement now. So yeah, it's very critical to understand the problem statement clearly, then only like we can come up with the right approach. So now let's try to come up with any working approach to solve this problem. So first let's try to calculate what are the total number of possible permutations that we can make or that is possible for any array of sizing. So here like n equals to 3. So if we observe clearly, like we have three different places or three different indexes that we need to fill with three distinct elements, 1 2 3. So let's say like I first decided to fill the index 0th element. Okay, so for that one, if we see like what are the total possibilities to fill this one, we can fill it using 1 or 2 or 3, because we have three distinct elements here, and using these numbers only like we can fill these positions. So if you see, we have total three possibilities. Okay, to populate this index 0th element. Now we have chosen one element from the distinct element of size n, that is 3. Now we will left with n minus 1 element. Let's say like I put here 1. So we will left with two distinct elements, 2 and 3. Okay. Now we have two different positions. So let's try to fill this position, that is at index 1. So for this one, we have two possibilities because we have two distinct elements. We could either choose 2 or 3. Okay. So we have two possibilities. Similarly, for this index or the last index, we would just end up with one possibility. Let's say like to fill this index, that is index 1, we have chosen 3. Now we would left with element 2 only. So we have one possibilities only. Like we can only choose 2. We don't have any other choice. So here if you see like this is 3 2 1, and if you remember or notice, so this is basically the factorial. So we can say here it's 3 factorial. And if we want to generalize it, so let's say like instead of n equals to 3 we have n equals to 5, then it would be 5 factorial. So we can say it's n factorial. So total number of possible permutations for any array of size n that consists of only distinct element is n factorial. Okay, otherwise if it consists of duplicate elements also, let's say like 1 1 3, Then in that cases, while generating the total number of possible permutations, it could be a case we end up with a duplicate list, for example. So we have two distinct element that is present, two duplicate element that is present at two distinct indices. Okay. So what we can do, like we can swap these two and try to put the element one at index one to element two index zero. So if we would end up with the same possibility. So if you compare these two, we are having the same element. And here what we did, we just tried to replace and put it here and this element to here. But since these two elements are same, we end up with the same possibilities. Okay. So we generalize considering the given problem statement for any array of size n that consists of distinct element only. Total number of unique permutations or possible permutations would be n factorial. Okay. So now we have to generate all the possible permutations. The standard approach that comes to our mind to solve such kind of problem where we have to try all the possibilities is backtracking. So we will try to utilize the same algorithm here to solve this problem. So in backtracking, generally, like this algorithm is designed or this approach is designed to take care of all the possibilities. And here, like our use case is also try all the possibilities and print it or return it. We can say, okay. So now let's try to interpret how we can utilize this backtracking to solve this problem. So here if you see like for each of the indexes, like we need to try with all the possibilities. So let's try to fix this index 0. At index 0, like we have to try all the possibility, like we could put 1 here, we could put 2 here, we could put 3 here. Okay. So for this index 0, we would end up with 3 possibilities. So let's say like the first possibility is this one where I populated 1 at index 0. The second possibility, let's say like I put 2 at index 0. Okay. And this is the third possibility. I put 3 at index 0. So while putting the element, yeah, you will see like I'm just swapping the element, okay? Because I can just try, I just have to try with this 3. So I just put 3 at the first, and after that I put 1 at the at corresponding index 2. Now for all these 3 array, okay, or 3 possible states or possible permutations, we have fixed the index 0. Okay. Now we have to take care of the remaining 2 element and remaining 2 indexes. Okay. So let's try to populate them. Now the first element is fixed. We have only 2 element and 2 different possibilities. So let's say like in the first possibilities, I am just putting 2 at index 0, at index 1. And the another possibilities I will just put 3 at index 1. Similarly for this one, 2 is already fixed. Similarly for this one, 3 is already fixed. So either at this index, one index could put 2 or 1. So one is this possibility and the another one is this possibility. So yeah, these are the total possible permutations we could have for this array of size 3. It is consisting of element 1, 2, 3. And if you compare it with the output, here you can see 1, 3, 2, 2, 1, 3, 2, 3, 1, 3, 2, 1, and 3, 1, 2. Okay, the ordering of the element doesn't matter, so we don't need to worry about that one. Let's try to calculate the time and space complexity of this approach. So the time complexity would be, we know the total number of permutations that could be possible for any array of size n is n factorial. So definitely like we need to process until and unless like we are done with all the permutations. To generate all the n factorial permutation, definitely like the time complexity would be n factorial, and after that like we need to print or store this element, then only like we can return this list of integer. And we know the individual size of an array is n, and to process it, it would take order of n. So the total time complexity would be order of n. And the space complexity, since we are not using any explicit space, but we are using the recursion to solve our problem. And recursion internally uses the system stack. So let's try to calculate the time complexity of that. Sorry, the space complexity of that implicit stack. So if you see the maximum height of this tree, because the way this recursion would work, first it will go to this path and this path. As soon as like it will done with this path, it will try this possibility. It will roll back and try this possibility and this possibility. So at any point of time, total number of elements that could be possible in our stack would be the height of the tree into this individual array size that we know n into h, where h is the height of the tree. Okay. Now we can calculate and finalize what would be the maximum size of this h. Okay. So we know for three elements we just have three indexes to populate. So it would be three only. So height 0, height 1, height 2. Index 0th element, index 1 element, and index 2 element. So it would become n square. Okay. The space complexity would become n square. The first n is coming from this one because even to store this single array, you need a size of order of n, and the max element that could be possible at any point of time in your recursion stack would be of height 3 only. For example, 1, 2, 3. This is a stack, and after that it has make a call to these places. So here again, like we are having with state 1, 2, 3, and again for this state, like we are having this 1, 2, 3, and after that we started rolling back. Pop out this limit as because we are done with the processing of this one. We'll start processing this possibility for 3 2. So at any point of time, the maximum size of the stack would be order of n, where n is the total number of distinct element or distinct size. So definitely, like this size would be the it would be equals to the number of distinct element. So yeah, the space complexity would be n square. Now let's try to code it. Okay. So we'll start with index 0. That's in just initializing one variable with 0. And we have to return this list of integer. Let's call it result. So we created an instance of this one. Now to store any temporary states, do we need to create? Okay, we don't need to create it. Okay. Let's name our function solve. Sorry, parameter. Let's define this method. Let's first thing. As soon as our index is equals to the nums length, then we are good. We can store that state basically. This is one of the possible permutations that we have found. So for that, what we can do, so whatever is the current state of this array, we need to persist it in our result set. Okay. And if you see the nature for this result set is list of integer. So let's create a temporary list of integer. Okay, let's populate the element of the array. Let's put this same thing. So if you want, we can return from here. Just get done with the processing. So here we have discussed for each of the indexes. So I'm starting currently with index equals to 0. We need to try all the possibilities. Basically, I mean, we need to put all the elements at that index, and then only like we should proceed ahead. So for our cases at index 0, we need to put 1, 2, and 3 and do the thing. So for that one, what I will do. So currently I index defined at 0, and this I will continue 0, 1, 2. So I will just swap the element that is present in this array at index I and index int. Okay. So after that, we would end up with the remaining element of size n minus 1, and distinct elements are also n minus 1. So for that one also, like we need to perform the same call, same recursive call, or same processing we can say. Input it. For the next call, we know like we have element 2 and 3. So that's why like I'm just skipping the first index processing because we already finalized this with all the possibilities with 1, 2, and 3. Now we need to roll back to the previous state so that we can try another possibilities also. So let's say like I at index 0 I first swap it with 1, and after that I swapped it with 2. Then I again we need to take care of this one swapping with 3 also. So we need to roll back to the previous state, otherwise what could happen at index 0. Let's say like I decided to put element 1 at this index. We can skip that part. Let's try to put this 2. So 213. This is the state, and we begin ahead and do the processing for the remaining whole. If we not roll back to the previous state, then we can't try the possibility of putting this 3 at index 0 because we know the element would get changed. Okay. So here, let's say like I try to put index 3 at index 2, then what we could end up 3, 1, 2. That is not the possible one. So that's why like we are rolling back to this one so that we can try the all another possibilities. Putting 3 here, no, 2, then 1. Okay, got it. Now we just need to implement this swap method. So it's a pretty simple method. Let's just implement it. Here we have to save nouns. It's named another index as x and y. And using any technique you can perform the swap. I will just use the standard technique to swap the two element using some third variable. So yeah, I think we are good with the coding part. Let's return the result here. And let's try to run the code and see whether it is working perfectly or not, or is there any compilation issue. Perfect, it seems to be working as expected. So let's try to validate using some of the another inputs to ensure its correctness. So yeah, that's it for today's tutorials.